All right, so we're going to go over the Chapter 15 practice quiz. All right, and we're going to use our new skills. So, a fast food restaurant just leased a new freezer and food fryer for 3 years. The service contract for the freezer offers unlimited repairs for a fee of $125 a year, plus $30 for a service charge for each repair needed. So what that means, right? If you have a restaurant and you've got like a bakery, or you've got some shop that you guys make stuff in the back. What this says is, you, instead of buying the freezer, instead of buying the stuff, you're just gonna like lease that, right? So that sorry, you're not having to buy it right out. You're just like renting it out, right? And then so every year you're going to pay $125, plus every time they have to come out to fix it, it's going to be $35. So if they come out once, it's 125 plus 35. If they have to come out twice, it's 125 plus 2 times 35, which would be 70. So 125 plus 70. Okay, you guys kind of understand. If they don't come out at all, it's just 125 plus 0. Okay. So this says the restaurant's research suggested that during a given year, 80% of these freezers need no repairs. So you got an 80% probability every year that the freezers don't need any sort of repairs. Okay. There's 11% chance needed to be serviced just once, 5% twice, 4% 3 times, and none required more than 3 repairs. And to give you a preview of your actual quiz, it's going to be the same exact word problem. Okay. This number will be different. That number will be different. These percentages will all be a little bit different, but it's the same exact, what we call STEM. It's the same exact question. I just change those numbers around. So if you can follow what I'm doing here, awesome. You should find 100% success on your actual quiz. Okay. So have that confidence. All right. Let's look at the first one. It says find the expected number of repairs this kind of freezer is expected to need each year. So we're going to start by saying E capital X. Okay. I'm going to do a little bit of scratch work over here on the side. I'm going to say, what did they say? They said, I don't need this right now. I need the 80%, 11%, 5, and 4%. So it says no repairs. We're going to say, let's do no repairs is going to be 80%. So I'm going to put 0.80. And then for one repair, that would be 11%. So I'm not doing a minus sign here. I'm just kind of like doing like a little dash to say 0 is 80%. 1 is 11%. Okay, twice is 5%, so 0.05. I'm kind of like writing this out for myself so that way I am just clear with what I'm doing. Okay. All right. Once again, that's not a minus sign. It's just a dash. Okay. And then 4 is more than 3. I'm not going to even write that. So what you have to do is you have to multiply. Sorry. You got to multiply the amount of repairs times the probability that repair is going to happen for that year, and then add it to each one. So it's simply going to be 0 times 0.80 plus 1 times 0.11 plus 2 times 0.05 plus 3 times 0.04. And you should notice that 80 plus 11 is 91, plus 5 is 96, plus 4 is that 100. Okay, so that's 100%. So 0 times 0.80 plus 1 times 0.11 plus 2 times 0.05 plus 3 times 0.04. Okay, so that's how you set it up. Okay, it's going to be, it's an 80% chance there's no repairs. That's what that says. But you're going to add that to this, add that to that, add it to that. Okay, you're just going to go through and do all of those probabilities. Okay. So if you remember from the practice, I actually had like fractions and stuff involved. When you're using just like these percentages and decimals, there's no more fractions involved with it, okay? Because they're kind of built into the problem. So I remember in the past, it just kind of clicked on me that some students wanted to take this and divide by something. And that was because in the practice that I showed you guys in the notes, there was one that looked like that, okay, that where I had to like actually subtract something or I had to divide by something. But that's when I was using fractions and I was like multiplying the number times the numerator, and I did that all the way across, and then I divided by that common denominator. Okay. In this case, when you're dealing with these percentages, right? These probabilities that are decimals, it's just simply this times this plus this times this plus this times this plus this times that. That's all you're doing. So let's take a look at it. 0 times anything is 0. 1 times anything is that thing. Okay. 2 times this is like 2 times 5, so you get 10 or 0.10. And then 3 times 4 is like 12, so 0.12. Okay. And then I add that together. 11, 10, and 12 is like what, 33? So the expected amount of pairs would be this. It would be this many repairs per year. Questions, comments, concerns? So you take the value, no repairs is 0, times its probability. Add it to 11% times 1, 5% times 2, 4% times 3, and that's it. Add them together. So this company would say, you know what? We expect 0.33 repairs per year. So that would kind of average out to about 1 out of every 3 years you might have to pay that $35 service charge. But as we know with averages and stuff, sometimes you might have 2 or 3 maybe repairs you got to do into a year. These numbers, these averages, right, are all about these bigger picture things. So where one company might have to have service calls every month, some companies might not ever have a service call for like a decade, okay? But some might have one every 3 years on average. That's kind of what they would expect, okay? All right. So question B now says find the standard deviation of the number of repairs each year. So the standard deviation equation, you start by doing the variance equation. So the way we practice and the way we had to do this is we're going to do it by hand, and we're going to do the variance equation first and then square root it to get the standard deviation value. So the way we write this one out, I'm just going to kind of do it just straight up like this. This is kind of how I like to do it without a lot of prep work, just straight doing the work. So what I do is I take the first number, 0, and I subtract it from the average of 0.33. Okay. I'm going to square that value and then multiply it again by its probability. So this equation will look almost exactly like this equation. The difference is it's going to be the value minus the average squared times the probability. And then it'll be plus this value minus the average squared times its probability, plus this value minus that squared. Okay, you guys see hopefully how it goes. So I'm going to do 1 minus 0.33, square it times its probability of 0.11. I can keep going. It's fine. And then this is going to be this minus that. Just for, well, I guess I'll probably have room. All right. Whew, that looks awesome, huh? So once again, this and this look pretty much exactly the same. The difference is instead of saying 0 times 0.0 or 0.80 or 80%, right? It's going to be the value minus the average we found squared times the probability. Okay, this is the variance. Once we get this number, we're going to square root that number, and that's what we get, what's called the standard deviation, and that's what we're actually looking for. So I would suggest, I'm going to plug it into a calculator. I'll do it the longer way. So I'm going to say 0 minus 0.33 will be, I'll just do it, and then square it. The square button on here is not. So, oh gosh. Okay, so I get that times 0.8. I'll do it this way. All right. So when I do something like this, I'm going to write as many decimals as I can, because I'm using a calculator. I'm just going to calculate each value individually. So I get 0.08712. All right. So when I did this into a calculator, it's 0.0 minus 0.33. Okay, and I did that, and then I multiplied by itself, and then I multiplied it by 0.8, and I got this answer. So I'm going to do this right now. Let's go back. Okay, the next one, 2 minus 0.33. Whoops. 1.67 times 1.67 times 0.05. Whoops, why did I put equal sign? All right, so what have I done so far? I did this one, I did this one, I did this one, and that's this last one. Cool, almost done with this problem. Okay, this last little guy here, I get 0.285156. Okay, I'm going to add this all up. When I do this, I get a variance of 0.5611. Okay. Now, the standard deviation, which is what we're actually looking for, we'll call it SD of x, is just the square root of the variance of x. Therefore, it is the square root of this number. Okay. So when I do the square root of this number, I get, in the calculator, I'm going to round it just to, let's just do 3 decimal places, 0.749. That's what I got. Okay. So I got an average or an expected value, right, of 0.33 repairs per year, plus or minus, right, the standard deviation of 0.749 repairs per year. All right. Any questions so far? This is just kind of going back to some old school style math, right? This times this plus this times this, all this kind of stuff. There's not a bunch of like writing and descriptions and graphs and things like that. It's just straight up plug it in, plug it in, just give the, Bill, read the question, answer the question. That's it. No funny stuff. So, okay. Last one here says, what's the mean and standard deviation of the restaurant's annual expense for the service contract? So here's how we're going to do this one. This one's new. This one we haven't done yet, but this is more of an application of the things we just found. So now we're going to try to put this into a price, because a lot of businesses want to, they want to know, how much will this cost me each year? Or what would I expect this to cost each year? So we're going to say this. This is like the formal way to do it. We're going to say let C equal to an equation. And that equation is going to be, this is $125 per year. So flat out, 125 bucks. Even with no repairs, it still costs you 125 bucks. But for every time they come out, they're going to charge you $35, which honestly is super cheap for repairs on this kind of level. That's why it's, you know, you're paying this because you might not use it, but if you do, you have the peace of mind that it's not going to cost, you know, $1,000 or $500 to fix. It's just 35 bucks plus that 125 you're already paying. So it's $35 for every single time they come out to work on things. So 35. However, we're going to multiply by X. X is the time where they come out for the repairs. So one more time, we're going to say let C equal to, so it's a new equation we call C, maybe it's for cost, okay? It's going to be 125 plus 35 times how many times they come out. So if they come out 0 times, it would just be 125. If they came out once, it'd be 125 plus 35. If it came out twice, it'd be 125 plus 35 times 2, which is 70. Hopefully you guys kind of understand what's happening. So what I'm going to find to get the expected value of the cost is going to be 125 plus this 35 times, no longer times X, because we know that the expected average is going to be 0.33. So when I solve this, let's go ahead and in a calculator, let's say 35 times 0.33. Okay, add that to 125 bucks, and we get 136.55. So my mean, or my expected value, my expected cost year after year, if this is my contract, okay, this would be the mean, okay? This is the expected value of the cost, okay? And then this would be the standard deviation of the cost, okay? That's the standard deviation of the cost. So we did the mean. Now we're going to do the standard deviation of the cost. Okay, so I did like the single underline here, double underline for this one. So to make sure this for your quiz, it'll be multiple choice and you're going to see both of these answers. Okay, so it's going to be kind of like a pair you have to select. So the way this one works, whenever you do a standard deviation deals with the spread of your data. Okay, the mean is a location of your data set. Like it tells you where in the middle is, right? Standard deviation kind of tells you kind of like the left and right, like kind of like the up and down, like it kind of tells you that, right? Like around this, right? Here's the middle, but what would you accept as like the numbers around it? Like what would you expect it to kind of be on the high end, low end without any outliers, right? You're trying to like get like a bigger picture of like, well, 136 is the average, but is it like a big variance, a small variance? Like, because if this had a variance of $1,000, well, shoot, you might actually be at $1,000 because of the, because of whatever's happening. So let's figure out the deviation to that. Okay, the standard deviations they call it, and all you have to do is you don't multiply by the flat fee, you only multiply by the scale, as they call it, this little multiplier of 35. So we're just going to say 35. Okay, don't do that part, just this part only for this number here. Okay, do not do the adding part, just do this second part right here. That was something we did like a few months ago, a few units ago, and that was discussing shifts and scales. 125 is a shift, 35 is considered a scale. With shifts and scales, you do that for position type numbers, but the scale is the only number you multiply to your spread type numbers like IQR and standard deviations. So I'm going to say 35 times 0.749, and I get a standard deviation of $26, and I'm going to round this to 22 cents. Okay, so they would expect to pay out $136.55 each year. However, this is a standard deviation of 26.22. So we wouldn't do it right now, but you would probably find like a decent little range to work with, and you would not drop below 125 because you got to pay 125 each year, but you might take 136 and add 26.22 maybe once or twice to your problem to get like an upper limit. Say, okay, can we afford like 150, 170 each year for service on our restaurant equipment? All right, so it has been about 20 minutes, which is kind of the limit that I wanted to reach today. That way you guys have time to take your quiz and review and ask questions. So I'm going to go ahead and stop the recording because we are done.